When you first encounter a limit like this, the limit as x approaching infinity of x minus ln x, you may think that this is a little bit weird, because when we put infinity here, we get infinity, and then minus infinity to ln, that's also infinity. So unfortunately, this is an indeterminate form because it is on my shirt right here. That means we have to do more work. But the thing is that we cannot combine fractions, and yeah, how do we even proceed right here, right? In order for us to use L'Hopital's rule, we must have either 0 over 0 or infinity over infinity. So what do? Well, check this out. For this one, let's again write down the limit as x approaching infinity. But look at this and that. Let's factor out one of them. Let's factor out the x. You can also factor out the ln, doesn't matter. And we will just get 1 minus, here we'll just do ln x over x. And if you multiply this in, we get back to the original. So we know this is good. And then let's check. Put infinity to here. Okay, that's infinity. And this time we multiply by, well, 1 minus, when we put infinity to here, ln infinity is infinity, and then over infinity to here, that's also infinity. Oh, it seems like this is no good. But you know what? Right here, we have infinity over infinity. Let's just do it on the side and see what this is. Yeah? Okay. So, we just have to supply some work on the side. Notice, when we have the limit as x approaching infinity of just ln x over x, don't worry about the minus. This right here gives us infinity over infinity, which is good because we can use L'Hopital's rule. So that means we can differentiate the top and then differentiate the bottom. And then we'll just end up with the limit as x approaching infinity. The top is going to give us 1 over x, and the bottom is going to just give us 1. Put infinity to here, we get 1 over infinity, and we can conclude that it's just equal to 0. So the truth is, once we have this right here, the first part is infinity, and then we can just say we are going to multiply that by 1 minus this. As x goes to infinity, we have done the work on the side already, and we can say that it's equal to 0. So this is what? Infinity times 1, which is just infinity. This is not an indeterminate form. Infinity times 1, alright? If we somehow end up with infinity times 0, then it is an indeterminate form. That's no good, but this is just infinity times 1. Conclude that the answer is just infinity. That's it.